Ladies and gentlemen, please welcome Jonathan Paskey, executive producer and co-founder at Dev Network.
Okay, we're rolling along here at DeveloperWeek Europe, day 2, our final day here at the conference. One of our 40 speakers here that's going to be coming on is our next keynote, David Hart, CTO and co-founder at NetFoundry. David's going to be talking to you about an application embedded zero trust using OpenZD. David, welcome to the main stage.
Thank you.
Yeah, welcome. Thanks for being here. Go ahead and take it away.
Great, thank you. So as mentioned, I'm Dave Hart. I'm the CTO and co-founder of NetFoundry. NetFoundry is the creator of, primary contributor to, and primary maintainers of the open source OpenZD project. And you can see our mascot Ziggy waving hello to you on the screen. OpenZD is a modern programmable network overlay with associated components for application embedded zero trust secure connectivity. We like to say that OpenZD was created by developers for developers. And one thing that we see, my background is mainly in SYN software, and it's in secure connectivity primarily, with some substantial background in the Internet of Things space. And one thing that was very promising about the Internet of Things, and remains promising, is that it uses the internet, which is a wonderful venue for innovation. But in my experience, some of our most successful customers doing some of the most important work had to spend a lot of time really managing and trying to understand and figure out a good solution for secure connectivity. So running VPNs or contracting out for dedicated circuits, or direct connect or fast connect, etc. And what we saw was that was a major time sink for people trying to do secure connectivity over the internet, and a major expense. And you'd see this tug of war between the teams responsible for security and compliance and the teams that were trying to innovate and move fast. So the bottleneck was often the developer would need to ask permission from an external organization. It might be internal, like a networking team or an IT team, or it might be so far as having to go talk with a telco or someone providing dedicated circuits. And the message that was being sent was that secure connectivity was too important to be left into the hands of the developer. And at NetFoundry, we feel exactly the opposite way, that secure connectivity is too important to be taken out of the hands of developers. And it's why open source is so important and fundamental to us and everything that we do. Now we have zero trust in the title, and zero trust is it's a great approach to looking at secure connectivity, but the word is really out there. The phrase is really out there nowadays, to the point where you get eye rolls when you see it. We had one of our engineers was presenting to a team of DevOps engineers on one of what we call a Zdification, where we added the OpenZD SDK directly into SSH in this case. And he said, he put it together, he gave a demonstration. He said, voila, now you have dark services that can't be found on the internet. And one of the people in the audience raised their hand and said, well, I already have dark services because I just don't tell my CISO about it. And that's, one of the issues, that when you have the external barriers to innovation, people find ways to get around it. When describing zero trust, it's really, you need to think of it more as a philosophy. Because in 2007, I believe, when Forrester produced a report called No Chewy Centers, where they used the analogy of an M&M with a hard, crispy, exterior representing, for instance, a firewall. If you broke that firewall, broke that exterior, you had this chewy center where all of your goods were now exposed and open. The other analogy that you often see is a castle and a moat. So the idea is the moat protects the castle. Everybody outside the moat is hostile. You're safe if you're inside the moat. And that's really insufficient, as it's been proven repeatedly, especially recently. The network doesn't exist to provide security. It exists to move bits from point A to point B. And the fundamental thing to have in your mind when you think about zero trust is you need to assume your network is hostile and you need to assume your network is compromised. And if your network is compromised and you're writing software that needs to run and communicate on that network, what would you do? So that's the mindset that leads to OpenZD. Now, we don't have time here to go into all the details of every aspect of Zero Trust, but I want to make sure that I highlight some of the important ones. We'll start here with the basic network, with the more modernized, with the castle and the moats removed. But the first concept that's important is you have to understand exactly who is on your network or who is trying to communicate across the network that you're ultimately running on. And that comes down to having very strong device identity, whether that device is acting as a client or a server, and following a core principle called authenticate before connect. So if you're trying to access, say, your bank, you're going to go to an HTTPS site, which is now open for attack. So a denial of service, for instance, or someone trying to crack passwords or whatever. It's a hole in the firewall. It's letting inbound traffic in. It's open to attack. So one fundamental concept is, you can think of it almost like a mini firewall, wrapped around each identity in the network. Authenticate before connect. So until we know who this actor is, we're not going to let him do anything. Now that's important, but it's not sufficient. So just knowing who the actor on your network is, you also need to prevent that person from, horizontal movement or accessing things that they shouldn't. So another important concept is least privilege access, meaning we only grant users and endpoints access to the specific services that they need at a specific time, and constantly reevaluate, should this user be able to access this service right now in these current conditions. So in this way, we'll see the dots combine, they'll be blocked from accessing the service. Now with Zero Trust, one of the common complaints that you'll hear is, well, I have to trust something, right? I can't communicate from point A to point B without some level of trust. And of course, there needs to be a level of trust. The main point is, like in the Forrester paper, the phrase they use was never trust, always verify. But an important concept is, how do I bootstrap trust? Where does my trust start? And OpenZD includes an enrollment framework that's designed to address this issue. And in this case, we can see an administrator, human, goes to an OpenZD controller and says, I need to add a new identity. This creates a signed JWT that's then distributed out of band to someone who has the ZD SDK, either your own app written as a developer or an app perhaps written by NetFoundry or someone else in the community. That application then verifies, by inspecting the JWT, that the controller listed in the JWT is who the controller says it is. So it goes and verifies the public key and makes sure that that controller actually signed this JWT. Then goes and creates its own private key, creates a certificate signing request, and ultimately ends up with a certificate that can be used to prove identity on the network. So that's the most fundamental aspect. Now, there's things in OpenZD that improve on this. For instance, OpenZD supports PKCS 11. So if you want to store that certificate and store your private key in a hardware security module, you can do that, something like YubiKey. And it's also built to be pluggable and extensible and replaceable. So you can delegate this bootstrapping of trust to, say, a third-party CA. Common scenario that we see when people are manufacturing devices and they need the identities to exist before we actually know which OpenZD network the device is on. Or recently we did, every Friday we do ZD TV streamed on YouTube. We did one that showed delegating this trust to Spire, which is an implementation of the SPIFFE protocol. SPIFFE stands for Secure Production Identity Framework for Everyone. But that's kind of fundamental, is with that identity, where do I start? How do I bootstrap that trust? There's a great series of 5 articles that you can see at zd.dev. This picture comes from Article 5, but I'd highly recommend having a look. Now, fundamental to OpenZD is a zero trust overlay. So I said modern programmable zero trust overlay. And the overlay we're most concerned with is the internet, which, as Gartner said a few years back, the internet's a cesspool. So there's really not a more dangerous place to be out in the open as the internet. OpenZD will overlay the internet, starting with the control function And this is where you can create identities, configure policies, enroll identities, etc. Distributed across the internet is our what we call fabric routers or ZD routers, shown in the middle. And we call those components the ZD fabric. So that's a mesh network that exists across the internet. And on the edges, you'll see edge routers. So if you look at the GitHub repository, you'll see a fabric repository. You'll see a ZD edge repository. The edge is built on the fabric, and it supports the idea of zero trust access across that fabric to services deployed also on ZD. And furthermore, we take care of, or OpenZD takes care of, making sure those connections are all trusted and that the identities are taken care of appropriately. So there's enrollment that happens for every component on the network with complete mutual TLS between each component. And the next major part of OpenZD are the ZD SDKs, written in various languages, that allow you to extend this overlay to your local environment or ultimately directly inside of your application so that you can have secure connections from an endpoint to a service based on policies that are configured that allow that access in ZD. And of course, with complete end-to-end encryption over that, on top of the existing MPLS connections. Now, when people deploy OpenZD, we'll see it deployed in different ways. You see each of these is listed with zero trust. The top two list zero trust, in double quotes. So ZTNA is a phrase that you'll open here for zero trust network access, or in this case, ZD network access. Where ZD is deployed, edge routers are deployed on the edges of local networks. Now that violates one of the core tenets of zero trust, saying I'm going to assume my network is hostile, but you can think of that deployment as maybe a better VPN. And in some instances, zero trust can be a long journey. To get started, you may need to start with a deployment like this, at least on one side of your server versus client-side connections. Think of that as, a better VPN. So I still have the strong identity. I still have least privilege access onto that network. I can reduce by policy what IP addresses, et cetera, are on the network. ZTHA is an improvement. OpenZD comes with endpoints that run on your host. They're called tunnelers. You can go to the App Store for iOS or the App Store for Android or the Mac App Store, or you can download a Windows client or a ZD tunnel client for Linux. This will allow access to a specific host that's either trying to access a service or provide a service. But it still lives in the realm of IP addresses and DNS because the application in this case does not embed ZD or zero trust directly into the app. The bottom is, in our opinion, the most secure and best approach, ZTAA, Zero Trust Application Access, where you use the ZD SDKs and embed that network, you embed the network via software directly into your application. I think it was around 2017, in the very early days of NetFoundry. Evan and Doug ultimately published a book, but before they published it, they did a series of talks that were most excellent about the experiences they had deploying zero trust techniques and solutions in the back end of PagerDuty. And their observations were dead on. So they said these are emergent properties of a zero trust network. Every flow, authenticated, encrypted, they're all authorized. There's no inherent value in IP addresses, which really, when you start working with software and a software overlay, this is one thing that really jumps out at you. I don't care what the IP address is. I care what service I'm trying to access, and I care who is trying to access that service. Nothing to do with IP addresses. The idea of centralized firewalls, network gateways, a private network that is trusted, gone. They're not concepts that you need to deal with. And of course, because this is being tracked with software, every flow you have complete visibility. And these properties certainly are true in OpenZD environments as well. And if I move in here to discuss application embedded zero trust in a little bit more detail, we'll see our friend Ziggy is back. We like to say that app embedded networking provides superpowers to your application. One of them, this relates to the emergent property of you don't care about IP addresses anymore. previously, if I wanted to send something to an application, it would be from some IP address and it would go to some other IP address, or it might be accessed via DNS. With ZD, you don't care anymore. Who's this coming from? Well, maybe it's coming from our friend Ziggy. Where's it going? Well, I'm sending a message to Jenkins. So the whole idea of worrying about DNS and worrying about IP addresses is totally abstracted and no longer a concern for the developer who's just trying to get his application written and provide his innovative solutions to the market. Another superpower, I mentioned the idea of an HTTPS site, or even with many IoT systems, you'll have the client, the thing, will be dark, right? I'm sitting at my web browser. What my IP address isn't something that I'm particularly concerned about at the moment. It's dark on the internet. There's a firewall sitting on my laptop, sitting at my home, that's blocking all inbound traffic. With OpenZD, the same is true on the internet side or on the server side. So your server is also dark to the internet. So you can have a firewall there with one rule that says don't allow any inbound traffic. So everything is dark, which gives a nice layer of protection. And also the idea of client server becomes less relevant, perhaps, in that you have a global mesh network of services and endpoints that can access those services. So rather than thinking about and worrying about things like HTTP long polling or managing WebSocket connections and keep alives, again, whether you're going from what you think of as your server side out to all your clients, or whether you're going from a client to a server, really not a concern. I am an endpoint. I am authenticated on the network. I am authorized to access a service. I just access it through a simple software call. Another superpower is that these flows are end-to-end encrypted. So it's a pluggable module where you can plug in different encryption technologies, but by default, we use libsodium. So you'll end up with end-to-end encryption from your app to your service, from your client side of your app to the service providing side of your app, 100% encrypted. And I mentioned this is all open source, so you can go read that code, you can contribute to that code. Libsodium implements encryption that's similar to what you'd see in Signal or WhatsApp. So anything that's traversing those fabric routers that I mentioned, or those edge routers that I mentioned, they have no chance of seeing what that data is. And inference isn't allowed. IBM's threat vector listed the number one point of concern is port scanning and exploits that are implemented by found ports, where all sides of your connections are dark and running on an overlay across the internet. There's no port scanning. The only ports that exist are, port 443 on those fabric routers. So your clients are not accessible. Your services, your servers are not accessible. You're not open to port scan. You're not open to denial of service attacks. And the other superpower is, frankly, it's easy. So OpenZD comes with a number of SDKs and a number of languages. The ZD Fabric and ZD Edge is written primarily in Golang, and we of course have Golang SDKs, but we also have JVM SDK written in Kotlin, available for use in Java. We have Swift SDKs, we have a .NET SDK, we have a C SDK, and others, Node.js SDKs. But if you look at the top example of before ZD, very simple. I'm going to open a socket, and I'm going to bind that to, in this case, localhost port 8080, and then a typical accept loop where I'm going to accept client connections, and I'm going to do something with those connections for my app. If you look at the after ZD box, you see it looks very similar. A couple new things show up. One is you see ZD init. It's a heavily overloaded function. In this init call, the identity file represents the results of that enrollment. Identity.pwd in this case represents your credentials to your key store. By default, the JVM SDK can use your local key store for storing your private key and your certificate. And then that Boolean at the end stands for seamless. In this case, it's set to false, but when it's set to true, ZD comes off the shelf with a default socket factory that whenever a socket is attempted to be created by your application, it goes ahead and creates a socket that uses the ZD overlay, consults the policies, verifies identities, everything that we've already spoken about, so that your application with really very small changes can be implemented to run right on the ZD overlay. And the important point here, I'll point out again, I know I've mentioned this a couple of times. There's no need in ZD when you bind that server to specify a listening port, because you're not listening. There's no need to specify an IP address. As I mentioned, we don't care about IP addresses. You're just specifying what the service name is on that network. And when someone wants to access it, assuming they are appropriately authenticated and authorized, they can access that with what would be a dial call in the parlance of the SDKs. Another thing that NetFoundry has done and opened up to the community is to create a number of what we call Zdifications. And this is where we take existing, typically open source applications, and just go ahead and embed ZD in it. Partly to show the way, and partly because we use these internally ourselves. We do a number of podcasts and presentations where we talk about how we've applied ZD, say, internally to our own DevOps environments. And as we do that, we build out things that we need. So things like SSH with ZD embedded. So now SSH is working 100% dark on the network. We have a series of articles that have been written that talk about, well, man, first thing I did is I made my Bastion server dark with ZD. The next thing I did is I got rid of the Bastion server because I really don't need that anymore either. Mattermost is something that we use internally at NetFoundry. It's an open source Slack alternative. We've done things like, the webhooks mentioned. The JDBC driver is nice. We call it ZDBC. So I can take an existing tool used to access a database, say I need to access in my production environment, using Squirrel or whatever I'm using to access my database. JDBC wrapper takes an existing JDBC driver and injects ZD into that driver. So again, very seamless, easy to use. Kubernetes environments, NATS for PubSub. We had a presentation yesterday where one of our developers presented how they Zdified Prometheus. So I recommend, if you have a chance, to watch that as well. And you can see those at the OpenZD Test Kitchen. Another set of applications that were written on the SDK, we call the tunnelers, and that's for that zero trust host access. And these are if you don't have access to the application source code, primarily from a client side, but it works client side and server side. How do I get as much of the goodness of OpenZD available for that application as possible? So these applications work with IP addresses. They can intercept local attempt for IP addresses. They can intercept DNS, which is a superpower, we say, of the tunnelers themselves. Given someone tries to make a DNS request, rather than going out over the internet to resolve that DNS request and opening ourselves up to DNS-based attacks, we resolve that locally right in that ZD tunneler and return a local address that we can then go ahead and tunnel directly over ZD. And what that means is you don't need to register a DNS address. You can do whatever you want. I could create a DNS address, configure it in ZD, call it DeveloperWeek.zd, call it Bodie McBoatface. It doesn't matter. That will be intercepted and automatically run over ZD. So if your application is written to use DNS for connectivity and you don't have access to the application or the ability to change that application, you can deploy a tunneler and go from there. And of course, it works with real DNS names too. You could go ahead and intercept google.com if that's what you needed to do. For instance, if you couldn't change the IP address or the DNS name or IP address the application was accessing. And I'll close it out with some words here on how do you get a hold of OpenZD. The first place I would highly recommend are the GitHub pages, openzd.github.io. And in particular, that docs link right at the top will give a very nice high-level overview. There's some nice getting started guides and automation for you, whether you want to start with a Docker environment or want to do Docker Compose, whether you want to host it yourself in one of the public clouds, you can go ahead and do that easily. And of course, access to the various SDKs. And the last set of links I'll leave you with are other places where you can learn more. The GitHub pages I mentioned CDTV. It's every Friday, right at about happy hour time, where we have a review of a recent Zdification or some use case of ZD live, hands-on, a developer using OpenZD in a real-world use cases. Twitter, of course, GitHub. GitHub.com, OpenZD. Discourse is where you can go to ask questions and get some answers to it. And I will close with one note. Number one, thank you for attending. Number two, if you don't mind, go ahead and go to github.com/openzd.zd and put a star in that repository and go ahead and follow it and keep up to date. And we appreciate it. I am going to attempt to stop my sharing. Thank you. And see if I have time to do to see if there's any questions here. There are a couple. Let's see if I'm in the same group. Wow, okay. With one foot in the developer world and the other in the exec world, any thoughts on how you've grown with respect to my philosophy? Yeah, absolutely. And it's I spend a lot of time talking to other CTOs. I'm in a hotel room. I spent the day yesterday talking with the CTO of one of our customers, and being given that he's a CTO, had an appreciation of the technical challenges, but he also had an appreciation of applying this to his business. So the idea, his feedback was, before I discovered OpenZD, I was deploying. I think he said when he got up to about 50 VPN tunnels, he realized that this world's just not gonna work for him. It's not scalable. It's not tenable. They were fielding more support tickets for their VPN connectivity than they were related to their core product offering. So it's the translation goes from my background as a developer. I want to be able to innovate, and I don't want to go explain and ask permission from anybody when I want to innovate. Because by definition, if I'm asking permission, I'm describing something incremental. What I need to do is get my hands onto it and start doing what I'm trying to do to understand it. Talking to now a growing customer base at NetFoundry, that translates, right? It doesn't just translate because companies need to move fast and companies need to innovate, which they do, but there's real world tangible issues that people run into when they're trying to solve this problem without it. The other set of executives we often run into, unfortunately, they contact us after they've had a breach or a violation. And that's a different kind of a conversation, but very directly impacting business. I could tell a couple of other stories, but I want to see if we can get to some other questions. Question on Refactor versus Rework. A lot of attention is given by the OpenZD team in particular to minimize the idea of rework. So the idea of like that socket factory, for instance, or the overloading the init so that the application doesn't change much. That's easier in some languages than others. Like Golang is set up very nicely for that. So if you have a Golang written application, it's really generally very easy. Java is set up nicely for that. Our original version of C was a little tougher. We used libuv. And did everything event-based. That's the same thing that's under the hood for Node.js. So if you've done Node.js programming, imagine trying to do that in C. We recently just changed that out to kind of use the same kind of technique you'd see with socket pair to create a ZD socket that can be used in your application. And then we can do cool things like go in and monkey patch Python socket.socket. So it now returns a ZD socket to, again, try and really reduce the idea of total rewrite versus minor refactors. You scroll down again. I think, am I out of time here?
All right. Thanks, David. I think we're just about out of time. But thank you for the great keynote, and we'll be back on the main stage in just a few minutes for our next session.
All right. Thank you.